Hey math enthusiast, I'm here to go over the notes for performing rotations. So the first thing I want to do is define that term. So it's another type of transformation in which the figure is turning about a fixed point, which is the center of rotation. So simply put, a rotation is just a turn. So I'm turning the figure. Now, every rotation has an angle of rotation. This tells me how many degrees the figure has turned. All right, that can be found by rays that are drawn from the center of rotation, going from the pre-image to the image. So as we said, a rotation is a turn, and rotations can be clockwise, or they can be counterclockwise. So obviously clockwise is going with the direction that the clock moves. Counterclockwise would be the opposite direction. All the rotations we're going to be performing in this section and future sections are going to be counterclockwise, unless otherwise stated. But the default is always going to be counterclockwise. So the next thing I want to figure out is when I rotate these points in the coordinate plane, how are they going to change? So let's start off with a sample point. Let's go with point A here at 3, 1. So what I want to do is I want to rotate point A 90 degrees counterclockwise. So I know right away it's going to move into the second quadrant. All right, what's going to happen when it rotates is it's going to move to this location after it's moved 90 degrees. All right, so think about this segment going from the origin to that point, and then I want to create a 90-degree angle to where my new point is going to be located. So now this is going to be A prime. And A prime is going to be located at -1, +3. So I want to think about how that coordinate has changed. It started off as an xy coordinate at 3, 1, and now it's gone to -1, +3. So what's happened is the y has moved to the front position and it's changed sign, and the x has moved to the back. So what I want to do after that is I want to rotate another 90, which is going to be a total of 180 degrees. So now I want to think about where this point is going to move to. So what's going to happen is it's going to move down here. Because remember, I want to create another right angle here. So what's going to happen is I'm going to end up with A double prime. Now A double prime is in the third quadrant where both my coordinates are going to be negative. A double prime ends up at -3, -1. So now I want to figure out what's my rule for 180. How did it change? We went from xy, which was at +3, +1, to -3, -1. So my x and y stayed in the same position, but both of them changed sign. Now what I want to do is rotate another 90 degrees. So that's going to be a total of 270 from my original point A. So you can kind of see where this is headed. So if I were to create another right angle here, I can see that A triple prime, we'll have to call it, because it's been moved 3 times, is going to move down into the fourth quadrant. So in this case, my x coordinate is going to be positive. It's actually going to be +1. And my y coordinate is going to be negative. In this case, -3. So now I want to try to come up with my rules. So my original point was xy. Remember that was 3, 1. And how has it changed now? Well, it looks like the y has moved to the front. The x has moved to the back, and it has changed sign. So it's kind of similar to my rule for 90, but the signs are going to be different. Now, what's going to happen if I rotate another 90 degrees? All right, where am I going to go back to? So now I'm going another right angle, which is going to take me right back to where I started, which is going to be x, comma, y. So if I rotate 360 degrees, my point, it's technically not going to change. It's going to be in the same exact location. So these are the rules that are going to help me out throughout this entire section. All right, because all the rotations we perform on the coordinate plane are going to be in increments of 90. So 90, 180, 270, or 360. So for this first example, I'm going to start off with this quadrilateral KLMN and the coordinates they give me. So let's graph that to start. So I plotted my 4 points. In this case, I didn't include labels. I should every time, but because my graph is a little small, I'm just going to leave them off this time. Now what I want to do with KLMN is rotate it 90 degrees counterclockwise about the origin. So first thing I want to remember is what's my rule for rotation of 90 degrees counterclockwise. All right, so if my original coordinate is xy, what's going to happen to it, we already figured out these rules earlier, is it's going to become negative y x. So what I want to do is I want to now apply that rule to all 4 of the points that make up that figure. So now k prime is going to become negative 2, positive 3. L prime is going to become negative 2, positive 4. M prime is going to end up positive 3 because my y coordinate is already negative, and positive 4. Same thing's going to happen with n prime. It's going to be positive 1, positive 2. And then I'm going to graph my new points, k prime, l prime, m prime, and n prime. And then you can kind of see in my graph that my original figure has rotated 90 degrees to become my new figure, my image. So for this next problem, now I want to rotate this figure 180 degrees about the origin. Now I'm going to come up with my new vertices for the image. So I've listed out my original points, and next thing I want to jot down is what is my rule for rotating 180 degrees. So if my original coordinate is xy, what's going to happen to it is it's going to change to negative x, negative y. So the coordinates aren't switching places at all, they're just changing signs. So now my new points, E prime is going to be at positive 6, negative 1. F prime is going to be at positive 5, negative 3. G prime is going to be at positive 2, negative 3. And lastly, D prime is going to be at positive 3, negative 1. Now for our next problem, number 4, we have a quadrilateral that's been rotated about point P. So point P is my center of rotation, and my angle of rotation is 110 degrees. Now, anytime I rotate a figure, I know that the rotation is an isometry. So it's some sort of transformation that preserves side length and angle measure. So in other words, it tells me that my two figures are still congruent even though they've moved in some way. So that means I can match up some sides in my picture here. So I know that this side on the bottom here is going to be congruent to this side right here. This side up top, we'll do 2 ticks here, is congruent to this side up top here. And then the side in between them, we'll use 3 ticks here, is going to be congruent to this side here. Now, what I want to try to do is solve for x and y. So let's try to set up a couple different equations. So let's start with this side that matches up to this one. So we have 3x equals 6. Now, another equation I can come up with is this side that is equal to this side. So I end up with 3x plus 1 equals 7y. Now, in this case, I'm going to want to start with this equation on the left first, because right away I can solve for x. And then what I'm going to do is I'm going to take that x value and substitute it in right here. So now I end up with 3 times 2 plus 1 equals 7y. So it looks like I end up with 7 equals 7y, which means that y equals 1. If I were to plug them in, that would tell me that this side length right here is 6, which is congruent to this one, and this side length right here is 7, which is congruent to this one. So for number 5, first thing I want to do is graph triangle ABC with the vertices they give me. Now, this is where it gets tricky, because the next thing they want me to do is graph the image of triangle ABC after a rotation of 180 degrees about this point right here, 1, 3. Now, we have a rule to rotate 180 degrees, but it's about the origin, not about some random point on the graph. So they want me to rotate around this point right here, 1, 3. Now, in order to perform this rotation using our rule, so remember for 180 degrees, the rule was to take your coordinate and switch the signs. So negative x, negative y. But the problem is I can't use that rule unless this center right here is moved to the origin. So what I'm going to do first is I'm going to take all my points A, B, and C, and I'm going to move them so that this center is at the origin. So I have my original points A, B, and C. And first thing I'm going to do is translate them so that this center moves to the origin. So in order to do that, I'm going to take my XY coordinates and I am going to move them 1 unit to the left, and I'm going to move them 3 units down. What's going to happen then is this center is going to move down to the origin, but all my points are going to move accordingly. So now I'm going to have new coordinates. So it looks like A prime is going to end up at 2, negative 3. Looks like B prime is going to end up at negative 2, negative 5. And then it looks like C prime is going to end up at negative 3, negative 4. So at this point, all I've done is I've just moved my center of rotation to the origin, and I moved all 3 of my points, A, B, and C, along with it. Now the center is located at the origin. Now what I'm going to do is I'm going to rotate it. So now I can apply this rule because the center of rotation is at the origin. Now I'm going to end up with a new set of points. So these are going to be my double primes. So now I'm going to end up with negative 2, positive 3, going to end up with b double prime, which is going to be at positive 2, positive 5. And I'm going to end up with c double prime, which is going to be at positive 3, positive 4. So I've successfully performed the rotation. But the problem is, it was about the origin, and I want it to be about this point. So now what I have to do is I have to undo what I did initially. So initially, I moved it 1 unit to the left and 3 units down. Now I want to translate it in the opposite direction back where it came from. So I'm going to go 1 unit to the right, and I'm going to go 3 units up. This will give me my final coordinates. So they're going to be triple prime now, but this is the end of the road. So A triple prime is going to be at negative 1, 6. B triple prime is going to be at 3, 8. And C triple prime is going to be at 4, 7. Last thing I want to do is just graph my final triangle. All right, some of it might be off the graph. Let's see. So now I've sketched out my triple prime points, obviously off the graph, but remember what I'm doing is I'm rotating 180 degrees about this point. All right, so it looks good. So for the last problem in the notes, I'm dealing with segment CD. And what I want to do is figure out where is my final segment going to end up, C double prime, D double prime, after both of these rotations. So I have my original points, negative 2, 2, negative 6, 4. First thing I want to do is rotate 270 about the origin. So 270 about the origin. We have a rule for this one. My xy coordinate is going to become y negative x. So now my new coordinates after the first rotation, it's going to end up being 2, positive 2. And d prime is going to end up being 4, positive 6. Now I have to perform the second rotation. So it's 90 degrees, but the problem is it's not about the origin. It's about this point 2, 0. So first thing I need to do is I need to move that center of rotation to the origin. So first I have to translate it. Now my rule to translate it to the origin is just to go 2 units to the left. So it's going to be x minus 2, and my y is just going to stay the same. It's not going to be moving up or down. I'm going to label these double prime because I'm moving again. So now it's going to be 0, 2 for C double prime, and D double prime is going to end up at 2, 6. So I've successfully moved my center of rotation to the origin. Now what I want to do is rotate 90. So my rule to rotate 90 is going to be negative y x. So now I got to come up with my new coordinates. So these are going to be my triple prime. So now it's going to become negative 2, 0. And D triple prime is going to be at negative 6, 2. So I have rotated 90 degrees, but now the problem is I rotated around the origin. So what I have to do is move all my points back so that they're centered around that point 2, 0. So now I just have to do the opposite of what I did at this step right here. So once again, I'm going to translate them. But instead of moving 2 units to the left, now I'm going to move 2 units to the right. So now C quad prime is going to end up at 0, 0, right at the origin. And D quad prime is going to end up at -4, 2. So this is my final answer. So this is actually what they were looking for. They were just calling it C double prime and D double prime because there's really only 2 movements that took place. It was just 2 rotations back to back. But this is my final answer.